Electron arrangement in the atom. Section 13.2. What is electron configuration? Electron configuration is the way in which the electrons are arranged around the nucleus. In most natural phenomena, changes proceed towards the lowest possible energy. High energy levels are unstable. Unstable systems will lose energy in order to become more stable. In the atom, electrons and the nucleus will interact in order to make the most stable arrangement possible. Aufbau principle. Electrons will enter the lowest energy orbitals first. The various orbitals within a sublevel of a principal energy level are always equal energy. The electrons, these are the orbitals for an element, and here would be the order in which the filling: 1s, 2s, 2p, 3s, 3p. The various orbitals within a sublevel of a principal energy level are always of equal energy. Example would be right here. The 2p has 3 sublevels, which means that it can hold a total of 6 electrons. Now each one of these orbitals, each one of these lines represents a place to hold 2 electrons. Each of these sublevels has the same amount of energy. So all the 2p here has the same amount of energy. We could look at the 2s and we could say the same thing. Each one of these electrons in the 2s has the same amount of energy. Within an energy level, the sublevel S is always the lowest energy level. Energy levels will overlap adjacent energy levels. Electrons enter the lowest energy first. Here is a diagram of the Aufbau diagram, and it shows that as you go up, you increase in energy. As you go out, it shows the order in which we'll come back to that. Aufbau diagram. This will show the order in which the filling happens. So starting here at the bottom, we start with the 1s. Then we go up to the 2s, then the 2p, then the 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s. So this shows the number of the order in which they fill, and in the process of showing this, we show how many spaces are available for electrons. So each one of these letters, 1s, represents a place for 2 electrons. So 2s has 2 electrons. Each one of these 2p's here shows that it can hold 2 electrons. It's similar to the diagram over here, where each line represents a place for 2 electrons. 2 electrons, 2 electrons, 2 electrons, and 2 electrons, and so on. Pauli exclusion principle. An atomic orbital may describe at most 2 electrons. That's what I was just talking about. To occupy the same orbital, 2 electrons must have opposite spin. The orbital containing paired electrons is written. Hund's rule. When electrons occupy orbitals of equal energy, 1 electron enters each orbital until all orbitals contain 2 electrons with 2 spins, denoting electron configuration. There are 2 ways. Number 1, use opposing arrows to denote electrons. So you will have an upspin and a downspin. This picture can represent the 1s diagram, or the 1s orbital. If you notice, each will fill the 1s orbital. This right here, this 2p, is not filled correctly. 2p is not filled correctly because we have the middle orbital is being filled with 2 spins, 1 up, 1 down. What we need to do is show that 1 up, 1 up, 1 up, and then we go back to the first slot, and then we start pairing them up. If you pair them up like this, it's incorrect. Here are 2 examples, one for carbon and one for oxygen with electron spin. This is done correctly. We've got 1, 2, 3, 4, 5, 6 electrons. We start with the lowest energy level first, 1s. 1 spin goes up, 1 spin goes down. Next one, 1 spin goes up, 1 spin goes down. That's the 2s. Now the 2p, we're going to fill 1 up, 1 up. We don't need to fill in the rest of the spaces with arrows because we don't have that many electrons. We'll take a look at the oxygen. Oxygen has 1, 2, 3, 4, 5, 6, 7, 8 electrons total, and we'll fill the lowest energy level first, the 1s, 1 up spin, 1 down spin. Then we'll do the 2s, 1 up spin, 1 down spin, and then we will fill up all up spin first, and then we'll go and do down spin, up spin, up spin, up spin, and then go back to the first suborbital in the 2p and fill in the down spin. We don't have to fill in the other orbitals because we don't have that many electrons.